Open your refrigerator and look at the milk. The paper carton with the folded peak on top, the one you pinch and pull open. A machine shop in Detroit built the machine that makes it. That same shop ground the lead screws that cut American engine blocks, cold formed the splines inside your transmission, and in 1961 shipped 35 grinding machines to the Soviet Union over the direct objection of the Pentagon. The company was called Excello. It ran for 87 years. However, outside of a machine shop, almost nobody has ever heard the name. This is Trade Archive. Highland Park in 1919 was the loudest place in America. The Ford Motor Company plant on Woodward Avenue had been running a moving assembly line for 6 years, and it had done something to the city that nobody had planned for. It had created a surplus of men who knew how to hold a 10,000th of an inch. Ford trained hundreds of them. But Ford could not hold all of them. And in 1919, a group of those toolmakers walked out of the Ford plant, rented a shop a few blocks away, and hung out a sign. Excello Tool and Manufacturing Company. The name was a joke and a promise at the same time. Excel. Say it out loud and it sounds like a boast, printed in 3 hyphenated syllables, and it looks like a part number. The Michigan Business Directory for 1921 lists the officers in the plain language of the era. Newton, a Woodworth president. Arthur E. Dunning, Secretary and Treasurer. General Machine Work. The address is 1214 Beaubien in downtown Detroit. Woodworth went by Woody. He is the closest thing this story has to a founder, and he would run the company for 18 years before walking away from it. Here is the first thing that makes Excello strange. A shop full of Ford men, sitting in the shadow of the Ford plant, in the automotive capital of the world, did not build its business on cars. It built it on airplanes. By the mid-1920s, roughly 60% of the work coming through the door was aviation, precision parts and fixtures for aircraft, at a moment when the American aircraft industry was still small enough to fit inside a few dozen hangars. Airframes were wood and fabric. Engines were temperamental, and the tolerances required to keep an air-cooled radial engine from tearing itself apart were tighter than anything Detroit needed for a Model T. The other early product was a spindle. In December 1921, a trade magazine described a line of air-driven high-speed grinding spindles coming out of the shop. That sounds minor. It is not. A grinding spindle is the thing that holds the abrasive wheel and spins it, and its accuracy sets a hard ceiling on the accuracy of everything the machine can produce. A spindle that runs out by 0.5 makes parts that are wrong by 0.5, forever, no matter how good the operator is. Excello learned early that if you own the spindle, you own the accuracy. In 1927, the company renamed itself to match the work. Excello Aircraft and Tool Corporation. It was also building grinding machines under contract for Carbaloy, the cemented carbide company, sold under the Carbaloy name, which is worth sitting with. Excello had been in business 8 years, and it was already the shop other manufacturers came to when they needed a machine built right and did not want to build it themselves. So how do you actually build a machine that is more accurate than the machines available to build it? This is the question underneath the entire history of the machine tool trade, and the answer is uncomfortable for anyone who believes industry is about automation. You do it by hand. A machine tool starts as gray iron castings, poured oversized, and then left alone. Good shops seasoned their castings outdoors through a full cycle of seasons, letting the internal stresses from the pour relax and the metal move before anyone cut it. A casting that has not been seasoned will keep moving after it is machined, and a bed that moves is a bed that is wrong. Then comes scraping. A man takes a hardened cast iron straight edge, coats it in Prussian blue, and lays it across the machined ways of the bed. He lifts it. The high spots are marked in blue. He takes a scraper, a chisel ground and honed to a specific edge, and shaves those high spots away in flakes you can barely see. He blues it again. He scrapes again. He does this for days. A good hand scraper works to 1/10 of a thousandth of an inch, and he does it with a straight edge and a smear of blue paste. in a room he can feel the temperature of on his skin. The XLO machines were hand-scraped and hand-fitted, and the men who owned them decades later would say so as a matter of course, the way you would mention that a table was solid oak. Then there is the lead screw problem, which is the deepest problem in the trade. If you want to grind an accurate thread, your machine has to move the workpiece a precise distance for every revolution. It does that with a lead screw, which is itself a thread, which had to be made accurate by some earlier machine, which had its own lead screw. The earliest XLO thread grinders solved this by carrying a master screw. The accuracy of every thread the machine produced was inherited directly from that one master, the way a copy inherits from an original. Shops kept libraries of them. One old XLO man reported holding more than 50 master lead screws, plus the cams for the cam dresser that shaped the grinding wheel. Errors were mapped inch by inch with a precision rule and a microscope, then compensated for mechanically. Later machines moved to change gears, and the numbers on the plate started to look more like arithmetic than inheritance. But the principle never changed. Precision is not manufactured. It is transferred from a master by a man who knows how to transfer it. Every ground thread that came off an XLO machine carried the fingerprints of that process. And a ground thread was smoother than a cut one, which meant the nut running on it lasted longer, which is why aircraft engine builders and machine tool builders paid for them. In 1937, Woody Woodworth left the company he had started. He went off to build his own venture. What he left behind reorganized under a shorter, flatter, more ambitious name, XLO Corporation. By the late 1930s, the catalog had thickened into a list of the specific machines heavy industry could not do without. Thread grinders in a numbered series that machinists would still be arguing about 80 years later, models 31, 33, 35, and 36. Precision boring machines, facing machines, lapping machines. The Model 33 nameplate, cast in brass, is now a thing collectors hunt for. And then, in the middle of all that, XLO accidentally took over the dairy industry. The story starts with a man in Toledo, Ohio, named John R. Van Wormer, who made toys for a living. Around 1912, he began filing patents on something that had nothing to do with toys: a milk bottle made of folded paper. The problem he was attacking was real. Glass milk bottles were heavy, they broke, and they came back to the dairy filthy and had to be washed, which meant every dairy was also running a sanitation plant. Van Wormer's answer was a flat paperboard blank that could be shipped stacked, folded into a box at the dairy, filled and thrown away. In his own patent language, the container was built so that opening it formed a sanitary pouring spout, and so that afterward the box was, in his words, absolutely unfitted for subsequent use as a sealed package. Use it once, throw it out. Nobody washes anything. He called it Pure Pack, and for the next 2 decades, it did not work. Not the idea. The machine. Folding, gluing, waterproofing, filling, and sealing a paper box full of liquid, continuously, without leaking, at a speed that made economic sense, turned out to be an engineering problem far past anything the dairy equipment industry could handle. Van Wormer sold the patents in 1928 to the American Paper Bottle Company. That company spent years and a substantial fortune building prototype machines. By the mid-1930s, it had a handful of them. None of them worked reliably. A carton that leaks is not a carton. It is a mess on a grocer's floor and a lawsuit waiting to happen. At the end of 1934, effectively out of money and out of ideas, they went to Detroit and knocked on the door of a machine tool company. In Elopak's own telling of the story, XLO was approached because it was regarded as the most renowned manufacturer of precision machines in the United States. And it worked, because the two problems were the same problem. Both were about holding a tolerance while something moved fast. XLO's engineers took the machine apart and rebuilt it around machine tool discipline. By 1936, they had one that ran. 24-quart cartons a minute, formed, waterproofed, filled, and closed. The waterproofing in those years was brutally simple. The formed paperboard was dipped bodily into a vat of hot paraffin wax, inside and out, and the wax sealed the fibers. It worked. It also flaked, and if the board was creased too hard, the wax cracked and the carton wept. That problem would take another 25 years to solve properly when the industry moved to a thin extruded polyethylene film bonded directly to the paper, which is what your carton is lined with today. The first commercial machines went in at Borden's in 1936. Sources disagree about whether the first plant was in New York or Ohio, and it is worth flagging that rather than pretending otherwise. By early 1937, there was a machine running at Risden Brothers in Detroit. By the end of that year, roughly 42 million pure pack cartons had gone out into the world. There was still one flaw. Van Wormer's original box had no opening mechanism worth the name. You cut it open with a knife or a pair of scissors. Excello engineered the top of the carton into the shape you know, the gable, with a spout that pulls out and folds back. That detail, more than the machine itself, is why the thing survived. Convenience closed the deal that hygiene had opened. Then the war came, and the shop went back to metal. Through the early 1940s, the Detroit plant on Martin Street turned out nozzle plates for rockets, aircraft engine components, boring machines, thread grinding machines, and center lapping machines. Not glamorous. Excello's war was fought upstream, in the tooling, building the machines that let other plants build weapons at volume. There is a story that gets attached to Excello here, and it needs correcting, because it is repeated constantly, and it is wrong. A few miles away, McCord Radiator and Manufacturing was doing something extraordinary. Of the roughly 22.3 million M1 steel helmets produced for American forces in the Second World War, McCord made somewhere close to 20 million of them. The manufacturing problem was the draw. You cannot easily pull a flat disc of hardened manganese steel into a bowl 7 inches deep without tearing it, and McCord worked out how to do it. Then the shells were rimmed, painted, and finished with finely ground cork mixed into the paint to kill the shine and break up the silhouette. McCord also built 210,000 flak helmets for bomber crews, flock-coated so they would not freeze to skin at altitude and shaped to sit over headphones. Excello did not do that. McCord was an independent Detroit company during the war. Excello bought it 32 years later. What Excello did get out of the war was aviation credibility, and it spent the next 20 years cashing it in. The company built fuel injectors for light aircraft engines, the A-42 and the models that followed, fitted to Continental engines, and sold to pilots as the thing that finally replaced the carburetor. It built the specialized tooling that jet engine components were machined on. And in 1948, it bought Robbins Engineering of Detroit, which made jet engine rotors, and which brought with it a line of magnetic chucks, sign bars, and sign plates. Small, unglamorous, and in every tool room in America. The bigger move came in the middle of the 1950s, when Excello bought the Michigan Tool Company, and with it, a process called RotoFlow. Here is what RotoFlow did. If you want to put splines on a shaft, the teeth that let a transmission shaft transmit torque without slipping, the traditional way is to cut them. You hob them, you shave them, you take metal away. RotoFlow did not cut. It rolled. The shaft was driven between hardened racks with the tooth form on them, under enormous pressure, and the steel flowed into the form cold. Nothing was removed. The metal was displaced, which means the grain structure of the steel followed the shape of the tooth instead of being sliced across it. The surface came out burnished rather than cut. The part was stronger and the finish was better, and it happened in seconds instead of minutes. Michigan Tool also brought in the Colonial Tool division, which made broaches and precision spindles. If you drove an American car in the second half of the 20th century, there is a real chance the splines in your driveline were formed on a machine descended from that acquisition, and the cylinder bores in your engine block were cut on an Excello transfer line. Then, in 1958, Excello bought a small company in Springfield, Vermont, and inherited a Cold War. Bryant chucking grinder internal grinders. Machines that grind the inside surface of a hole, running spindles at speeds that were, for the era, extraordinary. Their signature machine was called the Centiline, and the reason it mattered had nothing to do with Vermont. Every precision ball bearing in an American missile guidance system was made on a Bryant Centiline Model B. There were 72 of those machines in the United States, and the entire American ballistic missile program's ability to build gyroscopes rested on them. A guidance gyro spins on miniature bearings, and if the bearing races are not ground to a sphericity measured in millionths, the gyro drifts, and if the gyro drifts, the warhead misses. In 1961, the Soviet Union placed an order with Bryant for 35 Centiline Model B machines. The Department of Commerce approved the export. The Department of Defense formally objected, in writing, in February of 1961, on the grounds that the equipment was the most advanced of its kind in the world and that the Soviets had no equivalent. The objection was overridden. The Senate Internal Security Subcommittee opened hearings under the title Export of Ball-Bearing Machines to Russia, and one senator characterized the shipment as a matter of life and death. America only had 72 of these machines. It was proposing to sell an adversary 35. Critics of the deal, most prominently the economist Anthony Sutton, argued for decades afterward that the Soviet Union's ability to build accurate multiple warhead missiles traced directly back to that export. Excello owned Bryant when it happened. By then, the company had become something its founders would not have recognized. There were plants across the United States and overseas, including a facility opened at Bluffton, Ohio, in 1956 that built machine tools and pure pack machinery under one roof. In 1958, the company entered India through a joint venture in Bombay that eventually became XLO India, building steering gear assemblies and propeller shafts. In 1963, it bought Micromatic Hone, which brought precision honing machines and a line of rotary vane actuators called Rotac. In 1968, it bought Greenlee Brothers of Rockford, Illinois, and found itself in woodworking machinery. 26 plants, 15,000 people. A company that could sell you a thread grinder, a milk carton line, a fuel injector, a broach, and a spline roller, and did. Not all of that record is clean, and it should be said plainly rather than skipped. The Detroit shop floor in the post-war years was segregated in practice, and Excello was not an exception to that. Historians working from the United Auto Workers Fair Practices Department records document a walkout at an Excello plant in the summer of 1951 over the assignment of a black worker into a department that had been all white. UAW Local 49 was involved on the other side of it. Discrimination complaints against the company appear again in the archives in 1956 and again in 1962, filed through the Detroit Urban League. The specific numbers that circulate online about how many men walked out are not reliably sourced, and this script will not repeat them. In 1967, the company signed a federal consent decree in an antitrust case over price fixing in drill jig bushings, agreeing to stop and to issue new discount schedules. In 1970, it produced a piece of American labor law that outlived it. Workers at the Excello plant in Elwood, Indiana, had voted for the UAW. The company refused to bargain in order to test the certification in court, which stalls a new union for years. A trial examiner recommended that Excello be made to pay the workers what they would have earned had it bargained in good faith. The National Labor Relations Board ruled that it had no statutory authority to award that kind of compensation. That decision, Excello Corporation, 185 NLRB 107, is still the governing rule. The board reaffirmed it as recently as February of 2026. And then there is the strangest thing Excello ever accidentally did, which happened in a courtroom in London. In May of 1969, Butler Machine Tool Company quoted Excello's English subsidiary a price for a double-column plano miller, a very large milling machine. The price was £75,535. Delivery in 10 months. Butler's standard terms included a price variation clause, letting them charge more if their costs rose, and a clause saying their terms prevailed over anything the buyer sent back. Excello ordered the machine 4 days later, on its own purchase order, with its own terms, which contained no price variation clause at all. At the bottom of that order was a tear-off acknowledgement slip. It said the seller accepted the order on the terms stated on it. Butler signed the slip, returned it, and attached a letter saying the order was being entered in accordance with their original quotation. The machine was delivered in November 1970. Butler then invoiced an extra £2,892 under the price variation clause. Excello refused to pay. The case reached the Court of Appeal, and Lord Denning opened his judgment by calling it a battle of forms. The court held that Excello's order had not accepted Butler's offer. It had killed it and made a counteroffer. And Butler, by signing that little tear-off slip, had accepted the buyer's terms. The covering letter changed nothing. Excello won. And every law student in the common law world has been reading about a Plano miller ever since. By the late 1970s, the shape of the company had shifted again. In 1977, it bought McCord Corporation, 32 years after the helmets, moving heavily into automotive components. That deal brought over an executive named E. Paul Casey, and by the early 1980s, Casey was running Excello. Which brings us to the summer of 1986 and to Providence, Rhode Island. Textron was a conglomerate built on acquisition. Helicopters, defense contracting, financial services. In early August of 1986, it went after Excello without warning, offering $68 a share in cash. Roughly $966 million. Casey and the board turned it down. His reasoning was not that the company was not for sale. It was that the price ignored a restructuring already underway, and the value that restructuring was about to release. In his words, they wanted Excello shareholders to get paid today for those future benefits. Textron came back with $77.50 a share, an increase of $9.50. The total came to $1.02 billion for 13.2 million shares, and on August 18, 1986, both companies announced the deal. Textron's chief executive, Beverly Dolan, said afterward that the company turned out to be better than they had thought, that it was absolutely squeaky clean, and that they had found everything they were looking for. Read that back and notice what is missing from it. No mention of thread grinders, no mention of the tool room in Highland Park, or the master lead screws, or the 67 years of accumulated engineering judgment. Squeaky clean is an accountant's compliment. Textron had not bought a machine tool company. It had bought a balance sheet with a machine tool company attached to it, and it said so out loud on the day of the announcement. Excello at that moment employed 15,400 people, 2,600 of them in Michigan. 2 months later, in October, Textron announced that of the 195 corporate employees at the Excello headquarters in Troy, Michigan, 144 would be laid off. 51 were offered jobs. The building would be vacated by March. That is the whole RC of a conglomerate acquisition in a single quarter. What followed was a sale, division by division, and the logic of it was consistent enough to be predictable. Anything that fit Textron's aerospace and defense portfolio stayed. Anything that did not was inventory. The trouble with that logic is that Excello had never been organized around a portfolio. It was organized around a competence. The same discipline that let it grind a thread to millionths, let it fold a carton, roll a spline, hone a bore, and grind the inside of a bearing race. Those divisions looked unrelated on an organization chart, and they were not unrelated at all. They were the same skill pointed at different industries. Break them apart, and you get 5 modest businesses instead of one company that could do something nobody else could do. The packaging business went first, in 1987, and it went to a Norwegian company called Elopak, which closes a circle because Elopak existed because of Excello. It had been founded in February of 1957 by the Norwegian industrialist Johan Andresen and an engineer named Christian August Johansson for the express purpose of licensing pure pack technology for Europe. The name is an acronym: European License of Pure Pack. Their first plant opened at Spikkestad outside Oslo that November, and their first dairy customer signed the following year. 30 years after taking a license from Excello, Elopak bought the whole thing. The machines, the patents, the brand, worldwide. Today, Elopak sells more than 16 billion cartons a year in more than 70 countries, with a workforce of around 2,850 people. Van Wormer's dropped bottle, an Ohio toymaker's idea, ended up as a Norwegian company built on a Detroit machine shop's engineering. The machine tool side broke into pieces. The domestic operation was reorganized as Excello Machine Tools. The Rotoflow spline rolling business, the Michigan tool inheritance, was sold off, passed through private ownership, and ended up with Anderson Cook in 2017, still rolling splines. The German operations, which had grown into a serious cold forming and machine tool business of their own, were folded into the MAG Group in 2005 alongside other historic German names. And then, in one of the odder afterlives in industrial history, a Japanese cutting tool company bought the cold forming technology out of MAG and named the resulting business OSG Excello. It sits in Göppingen, in southern Germany, building CNC spline rolling machines. It broke ground on a new plant in 2024. The name on the building is the name a group of ex-Ford toolmakers picked in Highland Park in 1919, and the machines inside it are doing, with servo control and software, exactly what Michigan Tool's Rotoflow did with hardened racks in 1955. The American company did not get an afterlife. Excello Machine Tools kept shrinking through the 1990s and into the 2000s, a subsidiary inside a conglomerate that had no strategic use for it, in an industry that was leaving the country. On April 28, 2006, it began laying off its remaining employees. 87 years. Here is what Excello actually was. It was never a brand. It was infrastructure. The company sold almost nothing to a consumer in its entire history, and it touched consumers constantly, one layer back, through the machines it sold to the people who did. It ground the threads, it bored the blocks, it rolled the splines, it built the machine that folds the carton, and the reason the name vanished is the same reason it mattered. Precision does not announce itself. When a machine tool company does its job perfectly, the result is that nothing goes wrong somewhere else, in a factory you have never visited, on a part you will never see. The men who hand-scraped those ways in Detroit were building accuracy that would be inherited by machines they would never operate, making parts they would never hold. That is the trade. You transfer the tolerance forward, and you do not get your name on the finished thing. Excello machines are still running. There are shops today, small ones, still cutting threads on a machine with a brass nameplate from Highland Park, still keeping a shelf of master lead screws, still buying parts and service for equipment whose manufacturer has been dead for 20 years. A company in Holland, Michigan, exists in part to keep those machines alive, supplying spares for a builder that no longer exists. That is a better monument than a headquarters in Troy. If you want the rest of the trade, the companies that built the tools that built everything else, subscribe. The next one is already up on screen.